Good morning, class. Welcome. Today we want to look at switchgear and protective devices, and we shall start with the fundamentals of power systems protection. Now we can say the purpose of an electric power system is to generate and supply electrical energy to the consumers. The power systems should be designed and managed to deliver this energy to the utilization points with both reliability and economically. Let's look at zones of protection system. This one can be represented in a diagram showing all zones. That is zone 1 from the generating station. We have the zone 2 having two isolators protecting both the transformer and the generator. Now the power transformer, which is located mainly in the primary substation, is also protected immediately before the bus bar with another isolator. That is after zone 3. Now at zone 4 we mainly protect the feeders, that is feeder 1, 2 and 3, where we have the 3 isolators in each feeder. Now we can say an electric power system is divided into several protection zones. Each zone of protection contains one more component of power systems in addition to 2 circuit breakers. When a fault occurs within the boundary of a particular zone, then the protection system responsible for the protection of the zone acts by isolating the area where we have the fault. The circuit breakers are inserted normally between the component of the zones and the rest of the power systems. Thus, the location of the circuit breaker helps to define the boundary of the zones of protection. Now let's look at the different neighboring zones of protection are made to overlap each other. This is mainly to help to achieve maximum protection in case one zone fails to clear the fault. Now, however, occurrence of the fault within the overlapped region will initiate tripping sequence of different circuit breakers so that the minimum necessary to disconnect the faulty element. The primary protection, however, may fail. Now, what are the causes of the failure of the primary protection system? They include the following. We have the current or voltage supply to the relay. When there is no supply to the relay, definitely there will be a failure. We have the DC tripping voltage supply. Remember, circuit breakers are always powered using DC supply. So if there is no DC supply, then the system may fail. We have the protective relays, we have the tripping circuit, and finally we have the circuit breakers. Now let's look at the backup protection. What is a backup protection? A backup protection is the name given to a protection which backs up the primary protection whenever latter fails. In case the primary protection fails, the backup protection will assist in this. Now, the backup protection by definition is lower than the primary protection system. The design of the backup protection needs to be coordinated with the design of the primary protection, and essentially it is the second line of defense after the primary protection system fails. Let's look at the fundamentals requirements of or for a protection system in our design systems. What are the fundamental requirements? They include the following. Reliability, this is the ability of the protection systems to operate correctly. Next we have the speed. This is the minimum operating time to clear the fault in order to avoid damages to equipment. Another one is the selectivity. This feature aims only to clear the area where there is fault, while the area which are healthy are left to function correctly. And finally we have sensitivity, which is the smallest value of the actuating quantity at which the relay operates, detecting any abnormal condition. In other words, this is the smallest time taken for the fault to be cleared. That is under sensitivity. How long does it take to sense the fault and clear it? This marks the end of our lesson, and I wish you all the best.